This is section 1.2, looking at levels of measurement. And we are going to determine measurement levels for different variables here. But I wanted to look real quickly here at this little diagram, which I redesigned from last video. That way we can look at levels of measurement from lowest to highest level, beginning with nominal at the lowest. And look at it as going like up a staircase. So from nominal to ordinal, on that step, you add the ability to put categories in order. Then up another step, ordinal to interval, we keep order, but we add the ability to look at intervals or differences between data points. Then you go up to the highest step, highest level, that would be ratio level, and we keep the things from before, order and intervals, but we add the ability to look at ratios and we add a true zero to that system. So keep those in mind as we're looking at the ultimate measurement level here. On the nominal level, we just have categories. Ordinal level is if they can be put in order. Interval level, we can look at differences. These are little questions we can ask ourselves going along. And then on the ratio level, we'll focus on that idea of a true zero. That's pretty telling. Okay, so we'll answer whether each variable has each of these attributes, yes or no, and see what the highest level we get to is. So the highest step on this staircase. Okay, so looking at our first variable, hair color, there are categories to that, definitely. It is qualitative data, different hair colors like black, blonde, red, brown, rainbow, etc. So yes to that. Now, can they be put in order? Not really. There is not a set order to hair color. It doesn't, it's not dictated that brown hair comes before red hair, comes before blue hair, etc. So there isn't a set order to hair colors. Now, once you get a no on this, the other things should be no's as well. So no interval, no ratio. You can't look at differences like subtracting one hair color from another. And there is no true zero hair color. I mean, even white hair is a color. So our highest level that we've acquired here is just the nominal level of measurement. All right, zip code. So these are, the codes that the Postal Service uses to send your mail. In Livermore, we have a few different zip codes, 94550, 94551. There might be some others, but those are the two that I know. So they are categorizable. You can group houses together into their different zip codes. And ordered, yeah, we can put them in order. You can say this comes first and then this comes second, like counting through them. So yeah. Now, differences between zip codes. We could subtract those numbers and say, the difference between 94550 and 94551, the difference is 1. But in the interval level, those differences have to make sense and mean something. Like how in our example of years, you could find the number of years between 2021 and 1960, and that actually means something. In terms of zip code, finding the difference between those two zip codes to be 1 doesn't really have any meaning for what the Postal Service is doing. So the differences don't have meaning behind them. We don't get that interval level of measurement. And then there's also no true zero zip code. So this is the ordinal level of measurement. Now, kind of a funny thing on this one is notice that our zip codes technically are numerical there, but the ordinal level of measurement is qualitative data. So even though these look like numbers here, it is actually qualitative data in disguise. So this can be a bit tricky sometimes. Let's make a little note of that. Qualitative data in disguise. This happens on rare occasions. Because the zip codes are truly just a system, a representation. When the post when like the post office was making these, they might as well have made them letters. I mean, you could have had zip codes that were like something like that, and that could have been your zip code. The numbers don't really act as numbers in this case. It's weird to think about, but hopefully that kind of makes some sense to you guys. Like these didn't have to be numbers. It's just the way the system was set up. So it's actually qualitative data there. Kind of weird. Blew my mind a little bit the first time. Okay, let's talk about letter grades here, like grades in class, A, B, C, D, F. Those are categories. They do have an order to them. We could order them from like A to F or F to A if you're going decreasing or increasing. And then the differences. We cannot really do subtraction with those letters. If you take like A minus C, we don't get a meaningful result from that. If you broke it down into like percentage points or something, perhaps you could look at that, but then you're not looking at the letter grade anymore. You're looking at a percent grade. And that's different. All right, so no interval level and therefore no ratio. This is also ordinal level data. All right, next, ACT score. So this is a standardized assessment that some people take when they're leaving high school to get entry to colleges. It's kind of like the SAT. And the scores for this, I looked it up, they range from a score of 1 to a score of 36 for the main portion of the ACT test. And so we can see we have already hit like an ordinal level here because those numbers can be put in order. All right. And if we have ordinal level, we already inherit the nominal level there, categories. Interval, looking at differences. Let's say someone takes the ACT twice, and the first time they score a 15, and the second time they score a 21. We can look at the difference between that, and it is meaningful. That means they've increased their score by 6 points. So we do get the interval level of measurement there. Now, is there a true zero? Well, the lowest value we have is 1, and that's basically what you get if you go in apparently and like put your name on the paper and leave the rest blank, I guess. So 1 is not really a true zero to us. Yeah, we don't hit that ratio level of measurement. Um, yeah, I have to pause and think about that one for a second. Um, we do have the interval level of measurement here, but we didn't actually get a true zero level. Then looking at height, okay, height is different. There we can have a true zero, even if, kind of like the weight of kittens thing here, even if we're very unlikely to hit that. Um, Measuring height, there is a possibility of zero height, like no measurement, even if like no human actually hits that zero level, but there is a firm stop there. So if you hit that ratio level, you automatically have inherited everything from the previous steps. So we have differences that are meaningful, we have order to these values, and they are categorized. So we hit that highest level of ratio. Okay, now same type of thing with age. There is a true zero to that system, zero age. All right, I guess you might consider that like right as a baby is born. Um, but yeah, if we hit ratio level, we get the previous categories filled in. Ratio. And the last one is temperature in degrees Fahrenheit, which we already discussed a little bit in the previous video. So go back and listen to that if you'd like. But we do have numerical results in order here. Okay, so these are ordered values. And then looking at differences makes sense. All right, like subtracting one temperature from another. If it's 92 today, 87 yesterday, that is a difference of 5 degrees, which is meaningful. And true zero, do we have one? Well, that's what we were discussing, that there is not really a true zero in the Fahrenheit scale. Freezing is 32 degrees, boiling's 212. You can go into the negatives there. There is not a true zero, and ratios don't necessarily make sense here either. If you have a temperature of -5 degrees and a temperature of -10 degrees, is -10 necessarily twice as cold as -5? That is pretty subjective, as to how someone feels about that temperature. So the ratios don't have a whole lot of meaning to them there. All right, so this hits the interval level and stops. I'd say interval is, at least for me personally, the hardest level of measurement to conceptualize, because that true zero thing can be difficult to think about. But hopefully this helps out and you can determine measurement levels. I'd say keep that diagram here in mind. It's been a helpful one.